Hello, our topic is outbreak prediction using machine learning, and we are using the example of COVID-19. Machine learning is extremely important nowadays in outbreak forecasting.
There are different algorithms that can solve this problem. There is a large multitude of codes available when it comes to predicting how the outbreak will spread. And these codes have the same purpose, but they differ in implementation, calculation, and displaying of the data, making each one of them have their own benefits and flaws alike. Many codes have been analyzed, but only one of them will be covered for this short presentation. Without going into detail, one of these codes distinguishes itself by displaying a very large pool of information. The author creates tables showing each state from the US and displaying the most infected cities and the number of cases, deaths, and recoveries occurring in that city. These displays have been done using many different ways, such as pie charts, bar charts, tables, and graphs. For my implementation, I posted a video since it will be too much to cover in this presentation.
So the models that we have researched are logistic growth, exponential growth, support vector machine, and Bayesian rich regression. And we have used data set from Johns Hopkins University. This is how it looks. The logistic growth is S-shaped curve. It is usually used to predict the population growth. It is much better to predict epidemics than exponential growth because exponential never ends and logistic flattens after some time. This is the formula used for it, which was used for the code that I am presenting. So basically, the code helps to create linear regression, and then it lets me to manually fit some parameters. This is the link. Unfortunately, the video is almost 5 minutes long, so we have no time to play this now. But here is the link.
Also, the new SARS-CoV coronavirus has been identified in Wuhan, China, for the first time, and the World Health Organization named it COVID-19 for this disease. This presentation is aimed at the analysis of and projection of COVID-19 results. We use case data which was provided by Johns Hopkins University, and I also have a video here on the bottom. You can check the link after this presentation.
Exponential growth is used to find a maximum number that for people to be allowed to be together. Below you may find the formula of exponential growth, and on the side we have a simple exponential growth where you put the values in and you can work that out in the code. In here the main parameters are stated from 1 to 6 and explains what it does in the code. In here I have given an example of how the code works for a given scenario, that every 5 days 3 people gets infected, and if we maintain the social distance rules, this number can decrease drastically. In this illustration below, it shows the exponential growth, how it works for a given value of people infected. In this slide, if you click in the link, you'll be able to see my code for exponential growth.
So this is my code for logistic growth. It's almost 5 minutes, so I will just show some fragments. Here is the linear regression that is helping me to create logistic growth. Here I can fit some parameters manually, and after some more operations, I am getting my prediction for Sweden for next month. Thank you.